Now that we've taken a look at the graphs of limits as x approaches infinity and negative infinity, let's take a look at some laws as it relates to the equations or the analytical form. So first rule we're going to look at is for any n bigger than 0, the limit as x approaches infinity of x to the n is always going to be infinity. So for example, let's say n is 2 or n is 3 or 4 or 5, or actually it could even be a fraction. As x approaches infinity, that the y value will always also approach infinity. In other words, it will increase without bound. Now there's a couple ways to look at this. The first way we're going to look at is by the graph. So let's just say, so we said x to the n. Let's say n is 2. Okay, as x approaches infinity, y is going to increase without bound. So thinking about it, you're plugging numbers bigger and bigger in with an exponent that's positive. Of course, y is going to increase without bound. Let's do a decimal. Okay, even with a decimal, it's actually just going to get steeper and steeper. And the bigger that I make n, okay, let's try to drag the point back down. The bigger that I make n, the steeper the graph is going to be, and y is going to really jump up quick. So it's always going to increase without bound for any x to the n. So therefore, the limit as x approaches infinity of x to the n is infinity, provided n is bigger than 0. Okay, we're not talking about negative n values. Of course, we're going to look at that in a little bit. The other way to look at that is just numerically, right? I mean, if we plug in a really big number, so let's go back to the example of x cubed where n is 3. If we plug in a really big number in for x, 1,000, we're going to get a billion back. If we plug a million back, million cubed is going to be huge, like a trillion or a zillion. So y is just going to be increasing without bound whenever we have f of x equals x to the n as x approaches infinity. Now what happens if x approaches negative infinity? We're going to do that in the same video. Well, let's take a look. Let's actually go ahead and look at the first rule, and we'll explain why. So for all integers n bigger than 0, so an integer means, 1, 2, 3, 4, 5, 6, 7. If n is odd, then the limit as x approaches negative infinity of x to the n is going to be equal to negative infinity. So this n value has to be odd. So let's go back to the graph, and we'll go back to verify that rule. So let's make an odd number. Let's go back to n cubed. And let's make sure that x approaches negative infinity. So what happens? The y value is going to go down. Not up, but down. So the limit as x approaches negative infinity is going to be negative infinity whenever n is odd. I mean, we can do it for, let's say, n equals 5 as well. See how it looks very similar to n cubed. We could even make n equal to 1, right? And we can still see that as x approaches negative infinity, the y value is going to keep decreasing and decreasing. Now, numerically, this might be the best way to understand this rule. Why numerically? So let's make n odd, and let's plug in a really small number, right? So negative 1,000, or a really big negative number, if you want to say that. Because you're cubing the negative number or taking it to the 5th or the 7th, any negative to an odd power is still going to be negative, so you're going to get a really big negative number back. So that's another way to see why, as x approaches negative infinity, provided that n is odd, x to the n, the limit will be equal to negative infinity. Now let's look at the other rule. What happens if n is even? So let's go back to our graph, and let's just do n squared. That's the easiest one, right? Well, you're taking a negative number and you're raising it to an even power, so y is going to go up. All right, even if I make n equal to 4, we can see that it's going to go up, 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 and up. So the limit as x approaches negative infinity of x to the n when n is even is going to be positive infinity, as opposed to odd, it will become negative infinity. So the limit as x approaches negative infinity of x to the n is infinity. And again, if we look at that numerically, let's just say we have x squared where n is even. If we plug in a really big negative number in for x, it's just going to be, the negative is going to be squared, so it becomes positive, or to the 4th or to the 6th, it will become positive, and we'll get a really, really big number back. So therefore, it will approach infinity, and again, you can see that on the graph. So those are going to be the rules for now that we're going to worry about for this video. Limit as x approaches infinity of x to the n is going to increase without bound. It's going to be equal to infinity, provided n is bigger than 0. Second rule, limit as x approaches negative infinity of x to the n is going to be equal to negative infinity, and that's because if you raise a negative number to an odd power, it will remain negative and it will become bigger and bigger negative. But if n is even, then the limit as x approaches negative infinity of x to the n is infinity, because when you take an even exponent, a negative number, and raise it to an even exponent, it's just going to get bigger and bigger as x gets smaller and smaller. That's it for this video. If you have any other questions about it, let me know.